In this problem, we need to show that cosine of a plus b times cosine of a minus b equals cosine squared a minus sine squared b, and that's also equivalent to cosine squared b minus sine squared a. Let us begin. So we'll start our proof from the left hand side. So here we have on the left hand side cosine of the compound angle, which is the sum of two angles a plus b, multiplied to cosine of the difference of two angles, which gives us another compound angle a minus b. Now, we know that we're going to cosine of a plus b, so that can be also expanded as, so this is a standard identity, cosine of a times cosine of b minus sine of a multiplied to sine of b. And also, we have cosine of a minus b defined as cosine of a times cosine of b. Then this negative sign will become positive, everything else remains the same. So we have sine of a multiplied to sine of b. So we know this. So we can use this fact and rewrite a given expression as we have cosine of a times cosine of b minus sine of a multiplied to sine of b. So this will get multiplied to cosine of a minus b, but cosine of a minus b can be expressed as cosine of a times cosine of b plus sine of a minus times sine of b. Now clearly we can see here this is the formula a minus b multiplied to a plus b. So we know that that's a standard identity, the product of the difference of two numbers times the sum of the two numbers, that's equals to difference of the squares, which is a squared minus b squared. So using this we can expand it to get cosine squared a multiplied to cosine squared b minus sine squared a multiplied to sine squared b. So what we'll do here, we still have a few more steps to follow in order to reach this particular expression. Now what we'll do, we'll work with sine squared a and sine squared b, the second term. We will be using the identity. We know that sine squared theta and added to cosine squared theta, so that's a standard identity having a value of 1. Meaning we can express sine squared theta as 1 minus cosine squared theta. So let's begin by first working with sine squared a. So we can rewrite sine squared a in terms of cosine function as 1 minus cosine squared a. Everything else we are not going to change it. So we get cosine squared a multiplied to cosine squared b minus, now instead of sine squared a we'll have 1 minus cosine squared a whole multiplied to sine squared b. Fine. This will be equals to cosine squared a times cosine squared b. So let's distribute sine squared b with 1 minus cosine squared a. So that gives us negative sine squared b plus sine squared b times cosine squared a. Always be careful with signs whenever we're distributing. So we have a negative sign here and this is multiplied to negative cosine squared a. So we are getting positive cosine squared a. Now what we'll do, we can combine the first term and the third term, because here we have cosine squared a as the common factor. So if we take cosine squared a as the common factor, so that will get multiplied to, from the first term we'll be left with cosine squared b, and from the second term we'll be left with positive sine squared b. And we have the second term, which is negative sine squared b. Now cosine squared b plus sine squared b, that's a standard identity. So here theta is represented by b, so this value is going to be equals to 1. So we have cosine squared a multiplied to 1 minus sine squared b. So that's giving us a value cosine squared a minus sine squared b, which is the expression on the right hand side. So let's verify. We have obtained cosine squared a minus sine squared b. Now, in order to show that this is also equivalent to cosine squared b minus sine squared a, next what we can do, we'll start from this particular step and we can replace, earlier in the previous step, we replace sine squared a with 1 minus cosine squared a. This time what we'll do, we'll keep sine squared a fixed, but we are going to replace sine squared b with 1 minus cosine squared b. So let's write it down. So we can use the same idea here. So we can get sine squared b will be equals to 1 minus cosine squared b. So we will start from this particular step, cosine squared a. So we will keep the first term as it is, cosine squared a multiplied to cosine squared b minus sine squared a. So we're going to replace the value of sine squared b with 1 minus cosine squared b. So let's Further simplify this, we will get cosine squared A times cosine squared B minus, so sine squared A times 1 will be sine squared A. Then we have sine squared A times negative cosine squared B, so we get negative sine squared A times cosine squared B, but we also have a negative multiplied to it, so that becomes positive. So we get positive sine squared A times cosine squared B. Now what we'll do, we'll combine the first and the third term by taking cosine squared B as the common factor. So cosine squared B will be the common factor, so that gets multiplied to cosine squared A from the first term and sine squared A from the third term. And we're left with the second term, which is negative sine squared A. Cosine squared A plus sine squared A, so that's a standard identity having a value of positive 1. So we have cosine squared B times 1 minus sine squared A, and that gives us cosine squared B minus sine squared A, which is the expression on the right hand side. So we have successfully showed that the product of cosine of A plus B times cosine of A minus B, that's equals cosine squared A minus sine squared B, or cosine squared B minus sine squared A. This is a very special identity which will be used to solve other problems in the future.